All right, let's jump right in. If you're a Java developer, you live and breathe memory management. It's just part of the job, right? But what if I told you the entire mental model you have for Java memory is about to get a massive rewrite? Welcome to our deep dive on Java's big heap shift.
Yep, you heard that right. In 2026, with the arrival of Java 25, a core assumption we've all held for decades about how the JVM works is being completely flipped on its head. And trust me, this isn't some minor API update. We're talking about a foundational change to one of Java's most critical resources.
And that, of course, leads to the big question for you, the developer. Everything from the way you think about memory to the tools you use for monitoring and even your strategies for performance tuning, all of it is going to need an update. So let's get you ready for what's coming.
Now, before we can wrap our heads around this huge shift, we need to be crystal clear on how things work today. So let's do a quick refresher on the classic JVM memory model, the blueprint that pretty much every Java app in the world is built on.
So the JVM carves up its memory into 5 main areas. You've got the PC register, which is like a bookmark for which line of code is running, the code cache for the super fast compiled code, and Metaspace, which holds all the blueprints for your classes. But for our story today, we only care about the 2 big superstars, the stack and the heap, because that's where all of your application's data actually lives.
And here's the absolute key difference you got to remember. There's scope. The stack is like a private, super fast notepad for each thread. It's temporary, it's efficient, and it just holds local variables and pointers. The heap, on the other hand, that's the giant shared warehouse for the entire application. It's where all the actual objects are stored. So think of it this way. One is a private sticky note, the other is the company's central library.
Okay, enough with the theory. Let's make this totally concrete. The absolute best way to see the dance between the stack and the heap is with a single line of code. I mean, a line of code you've probably written thousands of times without even thinking about it.
And here it is. Student S equals new student Vijendra. So simple, right? But packed inside this one little line is the perfect illustration of how the stack and the heap work together. There are actually 2 completely separate things happening here, in 2 totally different places in memory.
First, let's look at the left side, student S. Now, this variable S, it isn't the student object, not at all. It's just a reference, basically a pointer. You can think of it as a tiny little slip of paper with a memory address written on it. And where does this tiny lightning-fast piece of paper live? It lives on that thread's private stack. Now for the right side. That new student part, that's the real heavy lifter. This is the command that actually goes out and allocates memory in that big shared warehouse, the heap. It builds the house, so to speak. This is where the actual object data, with all its variables and headers, gets stored. So remember the rule. The stack has the address, but the heap has the house.
Okay, so you've got the classic model down cold. Perfect. Now, get ready because we're about to throw a giant wrench in the works. The game changer here is virtual threads. They are the whole reason this memory revolution is happening. They were built to handle insane levels of concurrency. And to do that, well, they had to completely reinvent what a stack even is. And this is just brilliant. Here's how it works now. When you fire up a virtual thread, its stack is not a fixed chunk of memory anymore. Instead, it's a flexible Java object called a stack chunk. And guess where it lives? On the heap, right alongside all your other objects. When the thread needs to do some work, this chunk gets mounted onto a real OS thread. But the second it has to wait for something, like a network call, it gets unmounted and just goes back to being a regular old object on the heap.
So, why is this such a BFD? Well, here's the money shot. When you're running thousands, maybe even millions of virtual threads, you now have thousands or millions of their stacks just sitting there as objects on your Java heap. This puts a whole new and, frankly, massive strain on your garbage collector. It completely changes where you need to hunt for memory problems.
And that, right there, is the whole story. This is the heap shift. The job of managing stack memory has literally shifted from the operating system's native memory right onto the Java heap, where the garbage collector has to deal with it. The old boundaries have been completely redrawn. So what does this all mean for you and your day-to-day job? This isn't just some interesting trivia, this is your new playbook. Your monitoring tools have to change. You need to focus way more on deep heap analysis and GC behavior, not just watching native memory. You're probably going to need to rethink your GC tuning too, because the heap's got a brand new kind of workload.
And you know, writing code that doesn't create super deep stacks might just become a new best practice for virtual threads.
So let's just quickly recap everything. We have our classic definitions, right? Stack is for fast temporary references. Heap is for our shared objects. But now we have to add 2 new rules for the 2026 reality. Rule 1. Virtual thread stacks are now objects on the heap, which means more work for the GC. And Rule 2, which is the good news, the arrival of value objects will actually help us out by creating lightweight objects that reduce some of that heap pressure. It's a whole new balancing act.
And so we end right back where we started. In the world of modern, concurrent Java, the heap isn't just for your application's objects anymore. It's the new center of gravity for Java's entire memory universe. It's where your data lives, and now it's where your threads live too. The only real question left is your mental model ready to make that shift?